Imagine a world where the sun rises in the west and sets in the east. Now this isn't some fantasy tale or a distant exoplanet. It's right here in our own cosmic neighborhood. Welcome to Venus, Earth's celestial twin. It's a planet shrouded in thick, toxic clouds. But beneath that veil lies a secret so strange, it really challenges everything we thought we knew about how planets behave. Venus spins backward. Every other major planet in our solar system spins in the same direction, a kind of coordinated cosmic ballet. But Venus, well, it defies this rule. It spins clockwise, a lone rebel in the planetary family. Think of a spinning top. When you twist it, it spins around an imaginary line running through its center. This line is called its axis. Every planet in our solar system does the same thing. It spins on its axis, and this spin is what gives us day and night. It all started with a vast, slowly rotating cloud of gas and dust. As gravity pulled this cloud together to form the sun and the planets, its spin sped up. This is the same principle you see when an ice skater pulls their arms in to spin faster. This initial spin was passed on to all the planets that formed within the swirling disk. For centuries, Venus was a planet of pure mystery. It is our closest planetary neighbor, often shining brilliantly in our sky as the morning star or evening star. Yet it remained stubbornly hidden. An unbroken, permanent blanket of thick, yellowish clouds made mostly of sulfuric acid conceals its surface entirely. The breakthrough really came with the dawn of the space age and the development of powerful radar astronomy. Unlike visible light, which is blocked by Venus's thick clouds, radio waves can actually penetrate them. In the early 1960s, scientists at places like MIT's Lincoln Laboratory, Caltech's Jet Propulsion Laboratory, and the Arecibo Observatory down in Puerto Rico began bouncing powerful radar signals off the surface of Venus. By analyzing these echoes, scientists could finally start to map this hidden world. The technique works by measuring tiny shifts in the frequency of the returning radio waves. As the radar data from multiple observatories became more precise throughout 1962 and 1963, a consensus began to form. The results were undeniable, and they were utterly baffling. There was only one possible explanation. As unbelievable as it seemed, Venus was spinning backward. Let's just pause for a second to fully absorb the strangeness of these findings. First, a day on Venus lasts for 243 Earth days. This is the longest day of any major planet in our solar system. Just imagine standing on its surface. The sun would rise in the west, and it would take 117 Earth days for it to crawl across the sky and set in the east. The discovery of Venus's backward spin transformed the planet into a cosmic crime scene. The evidence was clear, a planet rotating the wrong way. The question for the detectives, the planetary scientists, was what force could be responsible for this planetary homicide? The theories that emerged fell into two main categories. One involved a sudden, cataclysmic event early in the solar system's history. The other proposed a slow, gradual process that unfolded over billions of years, a cosmic death by 1,000 cuts. Let's explore the most dramatic suspect first, the giant impact hypothesis. This theory proposes that sometime during the final stages of planet formation, a rogue object, perhaps as large as Mars or even Earth, slammed into the young Venus. The collision would have been an event of unimaginable violence, releasing more energy than all the nuclear weapons on Earth combined 1 billion times over. The sheer force of the collision, if it hit at just the right angle, could have been enough to reverse the planet's spin. This idea is not as far-fetched as it might sound. We have strong evidence that such giant impacts were a key part of how the inner planets formed. The leading theory for the formation of our own moon is that a Mars-sized object named Theia collided with the early Earth. However, the giant impact hypothesis has its challenges. To flip a planet's spin completely, the impact would have to be incredibly precise. It would need to be a head-on collision, or one that strikes the planet near its pole to deliver the rotational kick in the opposite direction. Now let's turn to the other main suspect, a much slower and more methodical culprit. This theory doesn't rely on a single violent event, but on the relentless gentle push and pull of gravity over eons. On Earth, the friction between the ocean water and the seabed slows our planet's rotation very slightly, making our days longer by about 1.7 milliseconds per century. This process is known as tidal braking. There is another key accomplice in the slow and steady theory, Venus's colossal atmosphere. Venus's atmosphere is incredibly thick, about 92 times more massive than Earth's. As the sun heats this dense atmosphere, it creates powerful thermal tides. The theory goes like this. For billions of years, the sun's gravitational tides won the tug of war, slowing Venus from a fast prograde spin down to a near standstill. But as the planet's rotation became incredibly slow, the balance of power shifted. So which story is true? Was Venus the victim of a violent celestial hit and run, or did it slowly surrender to the grinding forces of its own environment? The scientific community is still divided, and the truth may well involve elements of both theories. It's also possible that both mechanisms played a role. Perhaps an early impact didn't flip Venus completely, but it did tilt its axis significantly and disrupt its original spin. This initial blow might have set the stage for the tidal and atmospheric forces to take over more effectively. Let's bring the comparison closer to home. Venus is often called Earth's twin. This nickname makes sense at first glance. The two planets are remarkably similar in size, with Venus being about 95% of Earth's diameter. But when it comes to rotation, the two twins could not be more different. They are like identical twins who have walked down completely separate paths in life. Earth spins with a familiar, brisk pace. Our 24-hour day is a cornerstone of life itself. This rotation gives us a moderate and stable climate, preventing extreme temperature swings between day and night. Venus takes this familiar rhythm and turns it completely on its head. Its rotation is a crawl, not a sprint. A single day on Venus lasts for 243 Earth days. This is longer than its entire year. Let's zoom out now and look at the entire planetary family. Placing Venus in a lineup with all the other major planets in our solar system truly highlights its strangeness. 6 of the 8 planets are the good kids. They all spin prograde or counterclockwise, just as they were taught to do by the primordial solar nebula. Venus is not entirely alone in its strangeness. There is one other planet that breaks the prograde rule, Uranus. But when we look closer, we see that Uranus is strange in a completely different way. Uranus is the planet that got knocked over. Its axis of rotation is tilted by a staggering 98 degrees. This means it is essentially spinning on its side as it orbits the sun. The story of Venus's backward spin is, at its heart, a celebration of scientific curiosity. It began with astronomers who were not content to simply see a featureless, bright dot in the sky. This particular mystery is far from solved. The fact that we still don't have a definitive answer is not a failure. It is an invitation. It is a challenge to the next generation of scientists and engineers. As we continue to gaze upon the brilliant light of Venus in our morning and evening skies, we can remember that we are looking at a true rebel, a world that broke the rules. And in its defiance, it teaches us more about the cosmos and our place within it than any well-behaved planet ever could. Venus spins backward, and in doing so, it spins a tale of cosmic violence, patient forces, and the endless capacity of the universe to surprise us.